Hello. This presentation is going to take a few minutes to explain why methane is such a problem, how QLM is seeking to address it, and the quantum technology we are using to do so. Methane is, simply put, horrible. It is at least 84 times more potent a greenhouse gas than CO2 over a 20-year period, and the oil and gas sector emitted around 82 megatons of it in 2019. It does, however, present an opportunity. Its relatively short lifespan in the atmosphere, coupled with its potency, means that reducing global emissions of methane will have a quick, marked impact on the influence of climate change, buying time to deal with the longer-term problem of CO2. However, most methane monitoring systems available today are not up to the task. Leak detection and repair programs take place intermittently and involve time-consuming walkover studies that only provide a snapshot of the facility. If a piece of equipment leaks the day after the survey, it is missed until the next one. To achieve net zero, continuous monitoring is required, but no current solution offers the combination of detection, localization, quantification, and deployment at scale that the industry needs. This goal is QLM's mission. Based in Bristol in the UK, we seek to enable organisations to achieve net zero through the mitigation of greenhouse gas emissions. The company was founded by our CTO, Xiao Ai, based on his postgraduate research at the University of Bristol. Their quantum technology incubator, QTech, paired him with a business mentor in the form of our now CEO, Murray Reed, a Silicon Valley veteran with an eye for a winner. Underpinning the company's operation are our CSO and world-renowned optics expert, Professor John Rarity, and our chairman, Bernie Bolkin, an oil industry veteran with years of experience as BP's chief scientist. QLM's technology takes LiDAR, a range-finding point cloud technology refined for the autonomous vehicle industry, which has undergone dramatic cost and size reductions over the last decade, and combines it with quantum single-photon detection technology, capturing the tiny backscatter from the LiDAR and processing it spectroscopically. Matching the LiDAR wavelength and detector to the absorption wavelength of methane delivers a low-power, eye-safe, highly sensitive tunable diode LiDAR gas sensor, benefiting from a long operational range and off-the-shelf components that will allow for reductions in price as manufacturing scales in the future. At present, our minimum viable product is supplied as a fixed emplacement system on a pan tilt for mounting on a mast or tripod with an intuitive browser-based graphical user interface. It is able to monitor ambient methane all the way up to major super releases at a range of up to 200 meters and uses integrated wind speed and information data from an anemometer to calculate the associated leak flow rate with a high degree of accuracy. This performance has been tested using controlled release studies, notably at TADI, Europe's answer to METEC, where blind releases of methane were made at known times, but at unknown rates and positions about the test site. QLM's prototype equipment performed admirably, regularly detecting, localizing, and quantifying methane emissions over a wide dynamic range. QLM has generated industrial traction over the course of 2021. In April, we were named among the 2021 BNF Pioneers, a cohort of companies answering challenging questions about the fight against climate change, in our case that of continuous environmental monitoring. And in May, we successfully closed a seed round of funding, generating £3.1 million from a consortium representing both green technology and oil and gas interests, and providing a runway to a Series A funding round in 2023. We intend to use this funding to drive the camera development forwards. The camera is to be reduced in size and weight, which will enable it to be effectively flown from a UAV, adding in survey capability to the continuous fixed emplacement option. We will scale production, driving down the unit cost of the equipment. OSHA-compliant units will be produced that can be deployed into hazardous areas, units will be produced that can monitor different gas species, and the software package will be expanded to include the ability to fully automate greenhouse gas monitoring and incorporate it into site safety systems. QLM was brought about to enable organisations to achieve net zero through mitigation of greenhouse gas emissions. Our revolutionary quantum single-photon detection technology provides a true understanding of emissions of methane in the form of cameras that continuously visualise and quantify leaks and plumes as they occur. We are seeking industrial collaborators for real-world field trials, preferably involving onshore facilities over short-term deployments that will demonstrate the effectiveness of continuous monitoring over quarterly or half-yearly surveys. If you are interested in being part of this game-changing step forward in technology, please get in touch, and we will be happy to discuss further details.